Good afternoon, class, and today we're going to be learning Solving Systems of Linear Equations by Graphing 5.1. Welcome back.
Wow, that may be one of your best.
I don't know.
Alright, so guys, like I told you before we started the notes, alright, we're going to talk about this week, next academic week, we're going to talk about systems of equations. Now we're going to talk a little bit about what that is right now. The way we solve them will be different. So just based on the title of the lesson, how do you think we're going to solve today?
With linear equations.
Yeah, but how are we going to solve them? What
Graphing.
We're going to do graphing. That's why number 11 and number 12 in the warm-up, that's why we worked on y equals mx plus b. It's going to show up again today. That's why, again, to refresh your memory how to do it, that's why we did it in the warm-up. Alright? So again, you got some blanks to fill in on your guided notes on the stuff that's in bold. So a system of linear equations, so you want to fill in your first blank with that. System of linear equations is a set of two or more linear equations using the same variables. Right? Usually the variables will be x and y. Very rarely will we use something other than those variables. Alright? Usually we're going to have to solve for two variables. Alright, so you want to fill in the blank for 2 as well. Because stuff we've done up until now, in terms of working with equations, we've had something like this. Something like that to solve. Alright? But now we're getting into the word, we're talking about linear. What does that mean? Linear. What do you think? This based a line, right? Just like we did in the warm-up. Those were linear equations, right? Because it's going to give us a straight line. Maybe on an angle one way or the other. It may be vertical. It may be horizontal, right? But that's a linear equation. We've graphed them, but we've never asked you. We haven't asked you to solve them, right? Because now we're going to have to solve for two variables. When we have something like this, we only have to solve for one, right? Simple. Minus 4, 2x equals 1, divide by 2, x equals a half. We've done that, right? It's shown up in other stuff that we've done so far this year. Negative 1/2. Sorry, negative 1/2. All right. So we've done stuff like that. But now, when we have a system of equations, we're going to have two equations, not just one. They'll be stacked on top of each other, right? Each equation has to have an x, has to have a y. Or in most cases, they're going to have an x, they're going to have a y. There may be a number attached to the x. There may be a number attached to the y. All right? But in most cases, there's always going to be an x, there's always going to be a y. All right? So someone give me an example, and it doesn't have to be in slope-intercept form. It can be, but it doesn't have to. So think about the different criteria we talked about here. Has to have an x, has to have a y, has to have an equal sign. Somebody give me an equation that's an example of a linear equation. Joe?
2x plus 4 equals 8. No. What would that be?
So I'm going to write it up here. You said 2x plus what?
4 equals 8.
Is that a linear equation?
No.
Why?
No. Oh, wait.
So Joe, this is the example that Joe came up with. 2x plus 4 equals 8. Savannah?
For a linear, wouldn't it be like y equals like 5?
Okay, but do you agree that, do you say this is a linear equation or not?
It's not.
It's not. Why? Think about what you just told me.
Because there's an x value.
There's an x, but
There's no y.
there's no y. Correct. All right. So say what you were gonna say,
Y
Savannah.
equals 5.
Y equals
5.
5 what?
X.
Okay. And give me something else. Any number you want.
Oh, plus 2.
Plus 2. There's a linear equation right there. Yeah, but there's no, when you wrote, you never a y included in it.
Oh.
You could make this 4, you can make that 4y, you'd be fine. Or if you made that 8y, you'd be okay too. But you gotta have that x and you gotta have that y. So there's one example of a linear equation, right? Like we just said, we could just, Mr. Hager's gonna do that. Alright? He's gonna add a y to it. Equals 8. So that when you see a system of linear equations, this is how it's going to be written, just like this. They'll be stacked one on top of each other. All right? We have first one, we have a y, we have an x. We're good. Bottom one, we have an x, we have a y. We're good. All right? Now that top one, the y equals 5x plus 2. Could I just go ahead and graph that?
Which one?
The top one, y equals 5x plus 2. Is that ready to be graphed?
You kinda can if you put the y, the 5 over
No,
1.
since you had to
No, I agree. For the top one, we can graph that. Y is by itself, the x is in the right spot, everything's fine. I can graph that. But the bottom one is not, exactly. Alright, on the bottom, for the bottom one, what I'd have to do is, I'd have to like subtract 2x on both sides and do stuff like that. For the stuff we're doing this week, guys, we're not going to ask you to rearrange it and get it in slope-intercept form. All right, we're not looking so much for that. All right, one may show up, during a lesson today, but for the most part, they're going to be set up just like this. Y will be by itself. After the equal sign, you'll have the number with x, then you'll have the number at the end. But that's what a system of equations will look like. You have 2 equations. We're never going to give you 3. We're only going to give you 2. Right? So, again, we're going to talk about 3 ways that you can solve these. Right? Today we'll do graphing. We talked about that when we went over the title of the lesson. One way you can do it is by graphing. Tomorrow, Wednesday, Thursday, we'll show you another way. All right? And we'll look at those 2 ways for the test on Friday. Next academic week, we'll show you another way to solve them. So there's 3 different ways you can solve. All right? If I go down. So a solution of a system of linear equations in 2 variables is an ordered pair that satisfies each equation on the system. So basically what that means is I'm going to get 2 numbers. Somebody give me the example of an ordered pair.
1, 2, 3, 4.
I mean, a pair is just 2, right?
4, 6.
How's it? 4, 6, okay. So I'm going to write 4. I'm going to write 4. I'm going to write 6. Do I need to do anything else with that to make it look like an ordered pair? Comma. Put a comma in the middle. Anything else? Parentheses around them. That's an ordered pair. The 4 is which coordinate? Remember, when we're dealing with graphing, we have 2 coordinates. What's the 4, Mallory?
X.
4 is the x, and then 6 is the y. So basically, guys, when we get our solution, we can check it by plugging in a number for x and plugging in a number for y. So, what number would I plug in for x? I'd plug in 4 for x, and I'd plug in 6 for y. So, if I was going to do it for this top equation that we came up with, y equals 5x plus 2, I get 6 equals 5, 4 plus 2. So I'm just showing an example. If you wanted to check it, all right, that's how you do it. I'm going to I had y here, but it said my y coordinate was 6. I plug in 6 for y. X told me x was 4. It was next to a number, so I put parentheses around it to know I have to multiply. So now I'm written side by side, so I don't think it's 54. That's why I put the parentheses around it. All right? So that's how that works. For This week, we're gonna do, in terms of this idea, doing it by graphing, we'll work both ways. We'll give you the coordinate, all right? We'll say, okay, is 3, -2 a solution for the system? Or what we'll also do is make you graph it and figure out where the lines intersect. And that will be a solution. All right? And we have to check to see. And like we just talked about, so to determine if a given ordered pair is a solution to the system, plug the ordered pair into each equation and see if you get true statements. So it means what you get in each side should equal one another. If you plug in like one side's 20, when you do the math on the other side, it should be 20. If it doesn't match up, then it's not a solution. Alright, so on your notes, I think you have a spot that says, to determine if a given ordered pair is a solution to the system, you're going to write what's in bold. Right, Jack?
Yeah.
Did you write that stuff in bold on your notes?
Mm-hmm.
Okay. Mr. Hager's shaking his head no.
I'm doing it right now.
I'm doing it right now. Oh, okay, I'm sorry. My bad. So like I said, keep in mind, guys, there's a lot of ways to do this. All right? We're going to look at 3 different ways. We'll talk about graphing today, another way tomorrow and for the rest of the week, and then next academic week we'll show you the other way, or the other method that we'll use to solve systems. But you're going to see this stuff for the next couple weeks.
I think the next week, Mr. Roy, is the age word problems.
Oh.
Because that's kind of a messed up week, so.
What's next?
Alright, are we good? Put the Reese's away.
Do we have these?
That's what you want to me.
You want some?
Alright, are we good with, guys, are we good with this page?
No.
No?
Got that book.
Oh, sorry.
Okay, I'm done.
Right.
Just tell me.
Good enough? Everybody's all set? Okay. So let's go to the next page. So on your guided notes, we gave you the ordered pair. We didn't give you the system. We just gave you the ordered pair. All right. So here's the ordered pair, 2, 5. All right. Here's your system. So on your sheet, all right, you want to write it. You want to write x plus y equals 7. Then you want to write 2x minus 3y equals -11.
It's true, Bree. The first one's true.
All right. So I agree. We're going to get to that, but I would agree with that.
Are you guys always
Oh,
like
I
this?
forgot.
Like, I'm confused on what's going on.
All right. So guys, because I see sometimes on the notes when we put this is something that you may have not seen before. So sometimes on the notes, Mr. Hager and I on the guided notes will write the next example, but then some people will go ahead and do that. We leave the example blank because we want you guys to not go ahead of us. All right. What? All right. So, like on a test or on a homework or something like that, you would see this whole thing written. You'd see the ordered pair, all right, and you'd see the actual system. And we'd ask you, tell whether the ordered pair is a solution of the linear system. All right, so it's either going to be yes or it's going to be no. But again, you got to do the work to figure that out. All right, and like now that we just said, you have to plug in the numbers, like we talked about. We figured out how to do these type of problems. All right, so I'll scroll down a little bit. All right, so. Connor, 2, what coordinate is that? Or what letter is that representing?
X.
X. Good. And then what about, Ginny, what about 5? Why? So basically, guys, what this means is, wherever I see, or someone want to explain to me what that means. How is that going to help me with this problem?
You
Josiah?
have to put them in for the ones there in the problem.
Okay. Go ahead,
That
Sienna.
means for when there's X, you have to sub into when there's Y, you sub into.
Exactly. So basically, both of you guys are right. Both Josiah and Savannah are correct. Wherever I see X, X is gone. Put 2. Wherever I see Y, put 5. Everything else stays the same. So when you're doing this type of problem, there should be no, when you plug in, there should be no variables. All right, so Gemini, if I'm gonna plug in for my top equation, what would it be written out as?
2, just 2
Yeah, so 2 plus 5 equals 7. Everything else stays the same. The plus sign still stays there. The equal, the 7, stays there. The only thing that's changing is x and y. Everything else stays the same. That's my top one. Now, if I was going to do my math, all right, 2 plus 5 is what? 7 equals 7. Do we agree?
Yeah.
Yeah, sure. That works. Now, what if I was doing this type of problem and it didn't match up? What was on one side
You
didn't...
did it wrong.
It's not true.
You didn't do it wrong. Again, it may, because those numbers, they may not work.
It's not a
That ordered pair may not be a solution.
Where's Mark?
All right?
Who is
That's
that?
my boy Mark.
That ordered pair may not be a solution.
Isn't that kid an HVAC?
All right? Guys, pay attention, please. That ordered pair may not be a solution. Now, if I did that and it didn't work out, I'm going to stop. I'm not going to do any more. I'm not going to look to do the second one because I know the first one doesn't work. It has to work for both of these numbers have, in this ordered pair, have to work in both equations. So if it doesn't work on the first one you do, don't waste your time. Don't do more math than you need to. Just stop. It's not going to be a solution. All right? Now, for my second one.
That's the equation that you
For my second one, Madison, how am I going to set that up?
You're going to write 2
Yep.
parentheses 2
Yep.
minus 3 parentheses 5 equals -11.
Negative 11. All right. Will 2 times 2?
4.
How about when I do this?
Oh, -15.
Nice job. Then will 4 minus 15? Excellent. Good. Negative 11 equals negative 11. Does it check out?
Yeah.
Yes. So for this one, guys, 2 comma 5? Yes.
Okay, I kind of like this.
So on a test or something, you'd have to do the work, but it might be a multiple choice. A might be yes, B might be no. Circle the one that's correct. No, that's a good, guys, like Joe said, Mr. Roy, are we gonna use the same equation every time? No, the equations are always gonna be different. The ordered pairs we give you are gonna be different.
He only didn't put the next equation really wouldn't go on. He explained that.
Thank you, Susan. Alright, so we're good with this. Let's take a look at the next one. So this one, you have the ordered pair written, right? Negative 2 comma 0. You're going to write in on your thing, y equals negative 2x minus 4 for the top one, and y equals x plus 4 for your bottom. This is your system, right? 2 or more equations. So that is a system. All right?
Wait a minute.
So, Ginny, I know, okay, so negative 2, what letter is that? X, and 0 is going to be what? Y. We got that figured out. And, like Savannah told us, like Josiah told us, all right, wherever we see these variables or these letters, these numbers will take their place. When we plug in our numbers, we don't want any letters. There should be no letters. All right? So, for my top equation, Xander,
Which one?
with a Z. How would I write that out, plugging in those numbers?
0
Yep.
equals -2.
Minus 4. All right. So now, X. What are we going to do now?
Negative 2 times negative 2.
What do you get when you do that?
Oh no, so you're gonna 0 equals.
Oh, that's fine. I wrote that.
0 equals 4.
So so we had -2 times -2? Good. Positive what? Good.
Minus 1.
Alright, so first half, we're good. We did our math, we're good. 0 equals 0. Continue on. Alright, do you want to tell me, Josiah?
Yeah, it doesn't make sense. It does. The
Right.
first one goes with the second
So
one.
tell me, for the second one, tell me what the plugins, help me set it up.
Okay, so you do 0 equals -2 plus 4. And then you get -2. So
Doesn't check out.
No.
It's not true.
You didn't do anything wrong.
She did it.
What?
It's not.
Make sure your math too. Because 4 is bigger than 2 and 4 has the positive.
Yeah.
Making me look bad for a mistake. Alright, so here, again, and don't panic, guys. You're gonna get some on the homework tonight later in class that don't check out. We did our math correctly, it doesn't check out. No, not a solution. Alright, it's not a solution. Yeah.
So you put no for.
Okay, but
So I have to wait something.
in the one up there, you said that if we found one was correct, we would be fine. You didn't even have to go on.
No, what I'm saying is, what I said was, when you do the first one, the top one, if it doesn't check out, don't go do the second one. In this case, we had to do both because the first one worked.
Yeah.
But if the first one didn't work, don't go any further, you can stop. Because you know it's not a solution. Alright? So guys, this one, take a minute. Alright, well you obviously need a minute to write it out. Write it out, set it up, and solve it. If you're not sure how, look at the 2 examples we did before this. Alright guys,
Stop.
I touched that
She's not.
Josiah, you good? Connor, can you tell me what you wrote for the top one? Oh man, hold on. What happened then? We're good now. Sorry, Connor, go ahead, buddy. 4 equals what?
1.
There'll be a 1 there, right? What else is there too? So y is 4, I agree, equals 3.
Yes.
Then x is what? What's taking the place of x?
How'd you get 31?
What's taking the place? 1, right? And like you said, what should I do with it so I don't screw up?
How'd you
Exactly.
Get,
31.
there you go.
Oh,
Alright.
Yeah, Connor. Who just said yeah, Connor? It's like the difference.
So for that, we checked out, we're good. Alright? Fred, how about the second one, the bottom one? How am I going to set that up? Alright, so again, we know that, Savannah, can you tell me how to label these?
So 1 is X.
Good.
4 is Y.
Alright, so 1 is X and 4 is what? And 4 is Y. So, like we talked about at the beginning, and like Savannah and Josiah told us, wherever I see Y becomes whatever the number for Y is. Wherever I see X becomes whatever the number for X is. Alright? So how am I going to write it out?
Can I say it?
No.
Can I say it?
Fred's going to figure it out.
Oh.
So what, when we labeled, Fred, when we labeled, what number was Y? When we labeled, what number was Y? 4. You see Y here? What's it going to become? 4. Alright, so 4 equals, now I got a negative there, right? The negative just stays. It's nothing we're changing, nothing we're substituting for. And what's X? 1. Plus 5. If I do my math, 4 equals, again, 5 is bigger. We take the sign of the bigger number. 5 minus 1, 4. It checks out, so yes, it is a solution. Alright? So like we talked about, guys, we'll do somewhere we give you the coordinate, like we did those 3. Now the next thing we're gonna do is, you're gonna have to figure out the coordinate. And this goes along with what we did in the warm-up.
No, I'm good. What is this?
All right, it's on, you guys are on the back.
Oh!
Are they on the back, Mr. Way?
Yeah,
What is this? How is it?
I know, this is a different page.
In the examples that we just did,
Guys, this right here is not on your guided notes. It's just something to review.
which two examples worked? Which letters?
So A and C.
A and C. So what that means, because they worked, that means this coordinate, if you were to draw a picture of what I just pointed to, that coordinate would be on that line, and it would be on that line. It would be on both of them. So how can the same coordinate be on two different lines at the same time? How can that happen? The same coordinate on two different lines at the same time.
Negative and positive?
Because they intersect. Right? If you drew a line like this, and you drew a line like that, the coordinate in A and C is this one right there. It works on the black one, it worked on the red one. It's where the two lines crossed. And that's the whole key. When you sketch a picture yourself, you have to figure out where they cross. Now in general, that could be kind of hard, because if they cross at decimals, that's really tricky. So when we have you guys do this, they're always going to cross at nice numbers. No decimals, no fractions, just a very nice number, very easy to see. Okay? So the answer was if that's where the lines cross. So the solution to a system of linear equations is where the lines cross. So this is why in the warm-up we practice graphing. So now you guys got 3 steps.
Yeah.
Okay? In order to solve a system by graphing, these are the 3 steps. Step 1, graph your equations. If you're graphing, you're going to create a graph. How many are we going to be drawing at a time?
2.
2. We're only going to be doing 2 at a time. So step 1, graph each equation. Step 2, and this is the part we're going to make it pretty easy to see. Estimate where the lines cross. Once you do step 2, you should, if you do it correctly, you should have your answer to the problem now. What do you think step 3 is going to be? After you have an answer, what do we like to do with it sometime?
Record it.
Well, write it down, and then
Graph.
We already graphed the.
we already graphed. What do you want to do with your answer before I grade it?
Check it.
Check it.
Check it.
How do you check it? You guys just did that. You guys did this step with Mr. Roy.
So guys, like we did before, the ones we did before this, those 3, we gave you the coordinate, right? We gave you the coordinate to check. Now what we have to do is figure out that coordinate and then check it. So it's not going to be given to you. You have to graph those 2 lines to figure out where it intersects and then check it, just like we did for the first 3.
So compared to what Mr. Roy just did, step 1 is new. You didn't do that. Step 2 is new. Step 3, you've done that. Okay, anyone still copying down the 3 steps? Graph, estimate, check. That's how you could sum them up.
Yep.
Now, Mr. Hager said that second step, estimate, it's going to be, you're going to see, it's going to be a nice, it'll be a nice point.
Okay, so first of all, look at example 2A. Is that ready to graph? Are those the way we like to have our equations?
No. Yes. It's in y equals and it's supposed to be.
Yes, it is. It's y equals by itself. If it's y equals, you're good to
Nothing
go.
next to the x.
There's a 1 next
It
to it.
doesn't have.
You know what?
And like Joe, say what you said again.
There's a y there's a 1 next to the
Yes, if there's no number written next to the x, we can just put 1.
I think.
I know what you're saying, no, sorry.
Okay, you can always put the 1 over 1 if there's nothing there. All right, let's start. I'm going to just call this equation 1. Let's call that equation 2. Connor, what's my y-intercept in equation 1? 7. Now, the 7 means I'm going to put a dot on 7. Is that on the y-axis or the x-axis?
The y-axis.
The y.
Yeah, we don't call it the x-intercept, we call it the y-intercept.
So we've got a dot on 7. Now, this part right here gives me directions. Where do I go from that dot I just put to get another point? Up, down, and then right which way? How many?
You're gonna go down 1 and right 1.
We're going to go down 1, right 1. Now, one mistake I saw is when people did this, they went down 1 and put a dot. They went right 1 and put a dot. Don't do that. Go down 1, right 1, put 1 dot. Okay? Same thing again.
You gotta go in 2 directions. You're either going down to the right or up to the right.
Now,
we're gonna go down to the left.
I put a lot of dots because I'm trying to do this like really accurate. Okay? That's the one thing about graphing. If you don't have a ruler, if you don't have graph paper, this doesn't work. Because it's not accurate enough. You have to make your lines like perfectly straight.
I don't have.
Guys, don't worry too much. Anything we ask you to do is solve by graphing. We're gonna give you graphs. And I'm not gonna make you draw your own graphs.
Yeah, I don't like drawing my own graph.
Okay, so you're gonna have to draw the line, but he'll give you graph paper. That's what
Yeah.
You'll have the grid.
So there's our first one. Okay, second one. Who can tell me my y-intercept there?
Is 1.
1. So I'm going to put a dot on 1. And can somebody give me the directions to get to the next point?
So you're rise 1.
Rise 1. And then which way?
Run to the right.
To the right. Up 1, right 1. Now, if I do this enough times, watch what's going to happen.
Oh no, they're gonna do this way.
I already found the answer. I didn't even draw the second line yet, and I already have the answer.
I don't actually know.
But you should draw the second line. Okay, draw it in just like that. So now we've graphed. What's step 2?
So step 2 is estimate the point.
Estimate where they cross.
Oh, 3, 4.
Looks like 1, 2, 3. 1, 2, 3, 4. I agree with Joe.
Wow, okay.
Now you're at the step that Mr. Roy took you through. You've got your answer. Check it. Right? Let's check equation 1. What are we plugging in for y?
You're gonna plug in 3. I meant 4.
4. What are we plugging in for x?
3.
So I have 3, but there's a negative in front. What's negative 3 plus 7?
So it's 4.
That is 4. So did the point work in the first one?
Yeah.
Yes. But it also has to work.
The second one.
It's got to work in the second one. Let's check the second one. What are we plugging in for y?
4.
4. What are we plugging in for x?
3.
3. 3 plus 1?
4.
4. 4 equals 4. We're good. The point worked in both. So we got it.
How did you get 3, 4?
Once you draw your 2 lines, it's right where they cross.
That's what that coordinate
Go
is.
to the right,
It's
3 up.
it's 3 up. It's on the y-axis. It's on the x-axis at 3. It's on the y-axis.
So right 3.
Basically, what that point is.
What would happen if you had 2 lines that were parallel?
They would. It wouldn't be right.
What does that mean? What does that mean if the lines are parallel?
It's
Where would they cross?
Never.
Never. That can't happen. I don't know if that happens today. I don't think so. Does it? Does that happen?
No.
Oh, but
Can I help?
I want to go like this.
if you had lines that were parallel, they would never cross. So that's a no solution. We've done no solution stuff before. But today they will cross. Do we have a 2C? We'll probably skip.
I think this had the two. I think this had those 2 mistakes.
All right. So let's go through this graph, and then we have one word problem, and that'll be it. Well, then you guys have a few practice problems.
Yeah.
Why can't we just go with one?
Okay, without me guiding you, can somebody tell me what I would do? Let's call this equation 1. Equation 2. I want to start with equation 1.
You're gonna graph it.
Okay?
So you're gonna put 1 in for x.
Sure, you can fill in the ones if you want. 1 over 1.
And the y-intercept is 4.
Okay.
So you're gonna put 4. And then you're gonna.
How do I graph that y-intercept? You said it's 4, but if you said put 4, I'm not sure. Just put a 4
Y-intercept.
on the y-axis. So up 4, and now.
Then you're gonna go down 1.
Yep.
And over to the left, right?
To the right. Yep, we always go right.
Down to the right, always.
It's just deciding up or down. Down negative, up positive. Okay. Do that a few times.
Yeah.
Make your line. And I won't even use the line tool this time. I'm going to do it by hand. And I'm going to show you that it's probably still going to be easy enough to get the answer. All right, so if I just estimate.
And guys, that first line that you draw, like Mr. Hager just did, draw a couple do your slope a couple times. Like this one was down 1, right 1. Go down 1, right 1, 4 or 5 times. So you have a lot, so you know exactly where it will be.
Okay, can somebody guide me through graphing the second line? Someone different. Do what, Will?
Either side, negative 4 now.
Second, it's the bottom one.
Equation 2. What's my y-intercept for equation 2?
Oh,
Not sure?
yeah, sure.
Not sure? Decide?
-8.
-8. So how do I use that information?
You go to -8 on the y-axis.
Perfect. And now, here's my directions to get to the next point. What do I do from -8?
You go up 2 and over 1.
Yep. Up 2 and right 1.
Yeah.
Up 2 and right 1. I'm going to keep doing it,
Yeah.
and I think I already found my answer.
So guys, what Mr. Hager did right there, that's the most important thing. Keep doing the slope until you cross the line. Right, you can't just do it once, it won't cross. Keep going, like in that case, keep going up to right 1 until it crosses the other line.
Can somebody tell me what that location is? Where is it? Yes.
0.
0, 4 would be up 4. 4 is 0. But if you put 0, 4, hopefully you would have caught that when you check it, which is what we're going to do right now.
This is what?
Equation 1. Z. What's y?
Zero.
Yep. And what's x?
1, 4.
Which one? 1 or 4? You want to help him out? Which one and how do you know? Yeah. Sam?
Oh, wait. What are the numbers in? 4.
Why is it 4? How do you know?
Because x comes first.
Yeah. It comes from what we just did. It's the coordinate. So let's plug in 4, but remember there's a negative in front of it.
Yeah.
Oh, yeah.
-4 plus 4. We're good. Does that mean it's correct?
No.
Nope. It only means it works in the first one.
Guys, important thing is that negative. Don't forget that negative, right? That negative is part of the problem. But you can't forget that.
Okay. X. Can you remind me again? What's y?
0.
0. And then 2 times.
8, -8.
What's x? 4. X is 4. Y is 0. X is 4. Y is 0.
Wherever we see those numbers, we're always going to take the place of those letters. Everything else in the problem stays exactly the same. It does not change.
This one
So
goes
if 2
good, too.
isn't right, then the whole equation's not right, or just that part?
What's that?
So if the second part, like you get it wrong,
If the second part doesn't work, yeah.
The whole thing
is
is
the whole thing
The
wrong?
whole thing
or
is,
just
it
that
means
one?
it doesn't work. That means you found the wrong answer.
Oh.
If your lines cross and your answer doesn't work, that means you didn't write down the right point where they cross.
So it's.
So you got to try and fix it again.
Oh, okay.
Graph it again. What's 8 minus 8?
0.
0? We're good. That answer is good. It works. Okay, so that's a full problem. Graph, estimate, check your answer. Okay, last thing. For this one, you guys don't have to graph it. You don't have to graph it. All I want you to do is help me come up with equation 1 and equation 2. We're not going to graph them because the numbers are going to be big. So we're just going to come up with what's in that box.
Just setting them up. You don't have to solve.
So let's just read it first. So it says you sell small candles for $4, large candles for $6. You sell a total of $144 worth of candles at a craft fair. This information right here is going to help you to get your first equation. That's enough information. So let's call that equation 1. Equation 2 is the second sentence. It says you sell, it's another piece of information about what you sold. You sold 4 more large candles than small. Okay, when I'm putting a black box around, that is equation, we'll call it 2. So now we're going to translate what's in the red box and what's in the black box to a system of equations.
Again, guys, what do these equations need to have?
Number. X is variable.
All right, you're on the right track, Joe. It might be a y plus mx plus b, but what are you gonna need? A y and what else?
X.
An x. You need a y, you need an x. All right, you're gonna need an equal sign in there somewhere too.
So
we have to decide what is x going to mean in this problem.
What do you want those? So what 2 things are we trying to find here?
The amount of large and small.
Large and small candles, right?
But couldn't that vary? Because you could have like, let's say the numbers were like 5 and 6. If you sell 5 candles and like, I mean 5 and 5, you could do like 5 and 5 and then.
The prices could be different.
Yeah. So why is there an equation for something that could vary?
Well, there will only be one solution. It's kind of like if I said to you, there is a total of 15 students in here. How many are boys, how many are girls? You couldn't figure that out. Because if there's 15 students, there could be 14 boys, 1 girl.
Yeah, that's what I'm saying, so it could vary.
It could vary. That's where the second equation comes in. Let's say I said to you, there's not only 15 students in here, but there's twice as many boys as girls. That's going to narrow it down.
But is there?
I'm just making that up. So what do we want x to be? What is x going to represent?
X is gonna.
It's going to be a phrase.
Oh.
It's going to be a description in words.
X.
Small candles, sure. X is the number of small candles. So if x is going to be small candles,
Yeah, that's a no.
what's y?
Big candles.
Big candles. Large candles. Number of large candles. Okay, so let's start with the first part. You sell small candles. Each small candle is $4. What would you do with the number of small candles you sell and the $4 to find out how much money you made? Like if you sold 6 candles, each candle was $4. What would you do?
6 times 4.
You do 6 times 4. So what if you sold X candles and each candle was 4?
4 times X.
4 times X. Exactly. That right there is your amount of money from small candles.
That's how it is expressing it.
It's $4 times how many you sold. How many did you sell? We don't know. It's a variable. Now we're also selling large candles. If you sell small and large, how would you find the total sales?
Divide by subtracting large candles.
Like if I said you sold $20 in small candles, $50 in large, how much money did you
Divide the
make?
number of candles by the amount you made.
You would multiply then add them together.
No, I subtract.
Yes, you're gonna add.
Yeah.
Okay, so what we're figuring out is
Notice it.
this is the money from small candles. This is gonna be the money from large candles. So now, what would be your thing you would put under the large?
6.
6y. Each candle is $6, and you sold y of them. Now, it says the total amount of money you made is $144. So small money plus large money equals how much?
144.
144. There is equation 1. 4x plus 6y equals 144. I'm not having you guys graph that because the number is a little big. It would go off the page, so we're not doing it.
What is the answer to it though? Like what do we
We'll come back to this tomorrow.
Yeah.
Because the method we use tomorrow, Josiah, obviously won't be graphing, so if you have big numbers, you can still use this method.
Okay, now the last equation. You sell 4 more large candles than small. You sell 4 more large than small. Another way to think of it, large is 4 more than small. If it helps, think of it that way. Large is, what are we using for large?
6. Y.
Yep, just Y.
Y.
Fantastic. Don't have my.
So what we do y plus 4?
Well, large
is.
Large is 4 more than small. What operation in math means more? Or increase. Plus. 4 more than, last thing is small. So if you sold 1 small, 1 plus 4 would give you 5 large. Now together with these two equations, there is only one answer to that problem. But we're not going to do the
You
answer.
guys, we'll come back to this tomorrow.
Okay.
All right. So, guys, like we talked about at the beginning of class, we're gonna miss most of class on Wednesday, right? Because of the motivational speaker. It's gonna start at 1 o'clock. We're only gonna have the first 20 minutes or so of class. There will be a test on Friday this week. Now, do me a favor, guys, and stop packing up. Oh, you're packing. That's fine. All right.